In today's class, we're going to be looking at grade 11 inequalities. The first thing we're going to be doing is we're going to be revising grade 10 inequalities. So last year you guys learned that you can take information that's in interval notation or set builder notation, and you can go and write it on a number line. So in grade 11, anytime you see an inequality, you are going to be expected to sketch the inequality. So keep that in mind. Once you've simplified it, it does not mean you are finished. You are then going to have to go and draw the number line. So we remember from last year that when you have the equal sign at the bottom of your bigger than or smaller than sign, it means that it is included. In interval notation, it was then a square bracket, and on your number line, it was a colored in dot. When you didn't have the included sign at the bottom, it was always a round bracket, and it was an open dot saying that it's excluded. So if we go have a look at this interval notation over here, it says x is an element of numbers that lie between -2 and 1, where -2 is included but 1 is not included. So on a number line, it looked like this. So -2 is included, and it went all the way up to 1 where 1 was not included. All right, here's a second example. So x is an element of -infinity up to -3, where the -3 is included, and then again from 2 up to infinity, where 2 is not included. So it started at -infinity and ended at -3, so that's why it looks like that, the arrow pointing out to the left-hand side, and then again from 2 to positive infinity. All right, remember that your negative and positive infinity will always be in round brackets because you cannot define infinity. Now we get to the grade 11 inequalities. So this is your quadratic inequalities. With your quadratic inequalities, it works very similarly to how your the rest of your chapter 2 went. So you would have factorized it, you would have equated it to 0, and then you would have solved. In the first example that we're looking at, it has already been factorized for you, so then you can just go and get what we call your critical values. So x is going to be equal to -2, or x is going to be equal to 5. This is what we call critical values. When I have to go and sketch this, I have to go figure out, I've got one of two options. It is either going to be looking like this. It could obviously be colored in. I just mean the actual line where it's pointing. So it's either going to look like this, or it's going to look like this. It's going to look like this one over here, when whatever your answers are, your critical values, is going to be smaller than 0. So whenever they want you to end up with a negative answer. When your critical values or your equation is bigger than 0, then it's going to look like this, because we know that a negative times a negative gives me a positive, and a positive times a positive gives me a positive. Where with a 1 at the top, this would be a negative times a positive, and therefore I'm going to be ending up with a line in the middle. So if we go back to the example where we were, so this was bigger than 0, which means it is positive. We're looking for the positive values. So a negative times a negative gives me a positive. That's why it's pointing out to the -2 and to the -infinity from the 2. And then it's going to be positive where you've got a positive times a positive. That's why the 5 is pointing out to positive infinity. All right, in the second example, it's not been factorized. So in this case, you need to go and factorize it. And then upon inspection, you will see that it is smaller or equal to 0, which means we're looking for a negative value, in which case it's going to be facing inwards. All right. Now the next example that we're going to be doing, we have to go think carefully with this one. You cannot go and multiply that x plus 5 across. The reason you can't multiply it across is because if you do that, it's just going to disappear. And this is quite an important restriction. Because remember, anytime I divide by 0, it is going to give me undefined. So I have to keep that in mind when I go and draw my inequality. So for now, I'm just going to ignore that, and I'm just going to go and factorize that. It's a difference of squares, meaning my critical values are -2 and my other critical value is 2. Right, this is bigger or equal to 0, so we're looking at a positive value. So my critical values over here is going to be -2 to 2, and because it's positive, remember, it always points outwards. But now we have to be careful, because this bottom restriction over here, this x plus 5, is not allowed to be equal to 0, which means that x cannot be -5. So that's why I have to go and draw in my -5 over there. Because it's not included, I'm going to put an open dot over this one. My actual inequality was included, so I'm going to put a colored in dot over there, and also by my 2, I'm going to put a colored in dot. So remember, if we just look at the -2 and the 2, I said it's positive. When it's positive, it's going to be facing outwards. And in this case, it's not going to point to -infinity, it's going to stop at -5, right? Because we cannot actually solve for it from there. Then we can go and have a look at another one. This is what we call an unusual inequality. Right, so they say we need to go and solve for this. So if we had to bring this across, for example, it would look like that. And then if I had to go and get a root for it, it is going to look like that, which is absolute nonsense. So any number squared, right, will always be bigger than greater or equal to 0. Therefore, adding 1 to a squared number will always be greater than 0, no matter what the x value is. So we cannot actually go and solve for it, but we know that it will always be a positive value, because it doesn't matter what my x value is. If it's squared, it is automatically going to become a positive number. So all that I'm going to say here is that x is an element of real. Right, and that is all that you can actually go and indicate. If we have another one, for example, so one that looks like this, x squared plus 1 is smaller than 0. This one is no solution, because like I just explained to you, anytime you have a squared number, the negative is going to fall away and it's going to become a positive number. Therefore, there's no world in which a number squared plus 1 is going to give me a negative value. Therefore, there is no solution. All right. I hope that helped, and I'll see you guys in the next one.